MS Basargaon, Assistant Professor, Department of Human Design Sciences, Walchand Institute of Technology, Solapur. In this video, we are going to discuss Laplace transform part 2, learning outcome. At the end of this session, students will be able to find Laplace transform by using Laplace transform of standard functions. Now, first of all, we will see the Laplace transform of some standard functions. Now, in that, we will take first f of t equal to t raised to n. By definition of Laplace transform, L of f of t equal to e raised to minus st f of t dt. Therefore, here f of t is t raised to n. Therefore, Laplace transform of t raised to n is equal to integration from 0 to infinity e raised to minus st t raised to n dt. Now, here we have to integrate this integral, and now looking to the integrand, we can express this in terms of gamma function, and to express this in terms of gamma function, we can substitute s into t equal to x, that is dt equal to dx by s, and the limit will remain same. Therefore, Laplace transform of t raised to n is equal to integration from 0 to infinity e raised to minus x, we are putting s into t equal to x, and value of t will become x by s, that is x by s raised to n into dx by s, which is equal to this 1 by s raised to n and 1 by s we have taken outside the integral, that is 1 by s raised to n plus 1, integration from 0 to infinity e raised to minus x into x raised to n dx, which is equal to, we can write gamma of n plus 1 upon s raised to n plus 1. This is by using the definition of gamma function. And if n is positive integer, we can write the value of gamma of n plus 1 as a n factorial. Therefore, Laplace transform of t raised to n is n factorial by s raised to n plus 1. Now, second function, you take constant f of t equal to k. By using the definition, Laplace transform of k is equal to integration from 0 to infinity e raised to minus st k dt. And here k is constant, and integration of e raised to minus st is e raised to minus st upon minus s with the limit 0 to infinity, which is equal to k into, as t tends to infinity, e raised to minus st tends to 0. Therefore, for upper limit we get 0, minus of lower limit we get t equal to 0, that is e raised to 0 is 1, that is 1 upon minus s, that is k into minus of 1 upon minus s, which is equal to k by s. Therefore, Laplace transform of k is k by s. Next function, f of t equal to e raised to t. Therefore, Laplace transform of e raised to at is integration from 0 to infinity e raised to minus st into e raised to at dt, and which you can write is equal to integration from 0 to infinity e raised to minus st into e raised to at, you can write e raised to minus of s minus a into t dt, and integration of e raised to minus of s minus a into t dt is equal to e to the power minus of s minus a t divided by minus of s minus a, and for upper limit we get 0, minus of lower limit, that is minus minus plus, which is equal to 1 upon s minus a. Now, next function is f of t equal to e raised to minus at, and its Laplace transform will give similarly e raised to minus at is equal to 1 by s plus a, just changing a by minus a. Fifth function is f of t is sin at. Therefore, Laplace transform of sin at is integration from 0 to infinity e raised to minus st sin at dt, which is equal to, by using the formula of e raised to ax sin bx dx, here a is minus s and b is a, we can write the value of this integral as e raised to minus st upon minus s whole square, means s square, plus a square into bracket a, means minus s sin at minus a cos at with the limit 0 to infinity, which is equal to, as t tends to infinity e raised to minus st tends to 0. Therefore, for upper limit complete value will become 0, and for lower limit what we get, sin 0 is 0 and cos 0 is 1, that is 0 minus of minus a, which is equal to minus into minus plus a upon a square plus a square. Therefore, Laplace transform of sin a t is a upon a square plus a square. Similarly, by using the same method, we can find the Laplace transform of cos a t as s upon a square plus a square. Now, next function is hyperbolic of sin a t. Now, Laplace transform of hyperbolic of sin a t is equal to, and here we can make use of the identity sin hyperbolic a t. We can write e raised to a t minus e raised to minus a t by 2, which is equal to 1/2 of Laplace transform of e raised to a t minus Laplace transform of e raised to minus a t. And just now we have seen which is equal to 1/2 Laplace transform of e raised to a t is 1 upon s minus a minus Laplace transform of e raised to minus a t is 1 upon s plus a. By simplifying, which is equal to 1/2, taking the cross multiplication, you get s plus a minus of s minus a means minus s plus a divided by s minus a into s plus a, and here s will get cancelled. 2a divided by 2 means we get a, s minus a into s plus a is s square minus a square. Therefore, Laplace transform of hyperbolic of sin a t is a upon s square minus a square. Now, finally, the Laplace transform of cosine hyperbolic a t is equal to Laplace transform of e raised to a t plus e raised to minus a t by 2, because this is by definition of cosine hyperbolic function, which is equal to, we can write 1/2 Laplace transform of e raised to a t plus Laplace transform of e raised to minus a t, which is equal to 1/2 into 1 upon s minus a plus 1 upon s plus a by using the Laplace transform of e raised to a t and e raised to minus a t, which is equal to 1/2 of, again by simplifying we get s plus a plus s minus a upon s minus a into s plus a, which is equal to s upon s square minus a square. Now, this is what the table of Laplace transform. These are the standard functions and their Laplace transform. So, you have seen, that is in case of k, if you put k equal to 1, what we get? The Laplace transform of 1 is 1 by s, and we have seen Laplace transform of t raised to n is n factorial upon s raised to n plus 1. Laplace transform of e raised to a t is 1 upon s minus a. Laplace transform of e raised to minus a t is 1 upon s plus a. Laplace transform of sin a t is a upon s square plus a square. Laplace transform of cos a t is s upon s square plus a square, and Laplace transform of hyperbolic sin of a t is a upon s square minus a square, and Laplace transform of cosine hyperbolic of a t is s upon s square minus a square. Now, instead of using the definition of Laplace transform, we can make use of all these standard formula to find the Laplace transform of the given function by making use of the properties. Now, write down the following transforms of the following. Pause the video for a while and write down the Laplace transform of the following. I hope you have completed. As you know, Laplace transform of e raised to minus 4t, we can write 1 upon s plus 4, because we have seen Laplace transform of e raised to minus a t is 1 upon s plus a. Then Laplace transform of sin hyperbolic of 3t is 3 upon s square minus 3a square by using the Laplace transform of sin hyperbolic a t, and here a is 3. And Laplace transform of t raised to 5 is 5 factorial upon s raised to 6 by using the Laplace transform of t raised to n, where n is positive integer. And now we will see the linearity property. If k1, k2, k3 are constants and f1 of t, f2 of t, f3 of t are functions of t, then Laplace transform of k1 into f1 of t plus k2 into f2 of t plus k3 into f3 of t is equal to, constant term can be taken outside, that is k1 into Laplace transform of f1 of t plus k2 into Laplace transform of f2 of t plus k3 into Laplace transform of f3 of t. Here we have taken 3 constants and 3 functions, and it is applicable for any number of constants and functions. Now, using this property, we will solve the example. Find Laplace transform of e raised to 2t plus 4t cube minus 2 sin 3t plus 3 cos 3t. Now Laplace transform of e raised to 2t plus 4t cube minus 2 sin 3t plus 3 cos 3t is equal to, making use of this above property, we can write which is equal to Laplace transform of e raised to 2t. We can take here 4 outside, 4 into Laplace transform of t cube minus 2 into Laplace transform of sin 3t plus 3 into Laplace transform of cos of 3t. We already seen the Laplace transform of e raised to at, Laplace transform of t raised to n, Laplace transform of sin at and Laplace transform of cos at. By making use those formulae, we can write Laplace transform of e raised to 2t is 1 upon s minus 2 plus 4 into Laplace transform of t cube is 3 factorial by s raised to 4 minus 2 into Laplace transform of sin 3t is 3 upon s square plus 3 square plus 3 into Laplace transform of cos of 3t is s upon s square plus 3 square, which is equal to 1 by s minus 2. 4 into 3 factorial means 24 divided by s raised to 4 minus 2 into 3 is 6 divided by s square plus 9 plus 3s upon s square plus 9. This is what the Laplace transform of the given function. Next, second example, find the Laplace transform of sin 2t cos 3t. Here we have product of sin 2t and cos 3t is there. First of all, we have to make use of trigonometric formula of sin a cos b before writing the Laplace transform. Here we can write sin 2t cos 3t as a 1 by 2 sin of 2t plus 3t plus sin of 2t minus 3t by using the formula of sin a cos b as 1 half of sin a plus b plus sin a minus b, which is equal to 1 half of sin of 2t plus 3t, that is sin 5t, and sin of 2t minus 3t is sin of minus t, and sin of minus t is minus sin t. Therefore, Laplace transform of sin 2t into cos 3t equal to Laplace transform of 1 half sin 5t minus sin t. Now, by using the linearity property, 1 half into Laplace transform of sin 5t minus Laplace transform of sin t, which is equal to 1 half Laplace transform of sin of 5t is 5 upon s square plus 5 square means 25 minus Laplace transform of sin t is 1 upon s square plus 1 by using the Laplace transform of sin at. Next, we will see find the Laplace transform of cos of at plus b. Laplace transform of cos of at plus b equal to Laplace transform of cos at cos b minus sin at sin b using the formula of cos at plus b, which is equal to, here cos b is constant, that is cos b into Laplace transform of cos at minus sin b into Laplace transform of sin at, which is equal to cos b into Laplace transform of cos at is s upon s square plus a square minus sin b into Laplace transform of sin at is a upon s square plus a square. Now, finally, we will see one more Laplace transform of sin cube t. We know sin 3t equal to 3 sin theta minus 4 sin cube theta. Sin cube theta you can write 1 by 4 3 sin theta minus sin 3 theta, and here theta is 2t. Therefore, sin cube 2t can be written as 1 by 4 into 3 sin 2t minus sin 6t. Therefore, Laplace transform of sin cube 2t is Laplace transform of 1 by 4 into 3 sin t minus sin 6t. That is, by using linearity property, 1 by 4 into Laplace transform of sin 3t minus Laplace transform of sin 6t, which is equal to 1 by 4 into 3 into Laplace transform of sin 2t is 2 upon s square plus 2 square, and Laplace transform of sin 6t is 6 upon s square plus 6 square, which is equal to 3 by 2 taking 6 common, then 1 upon s square plus 4 minus 1 upon s square plus 36 taking LCM. We can write, for simplification of this will be 48 upon s square plus 4 into s square plus 36. Thank you. References: Higher Engineering Mathematics by Dr. B.S. Grewal.